Hey class, it's Mrs. Lowe here. As promised, I'm going to do a problem on the calculator that requires you to find the exponential regression model. And this is from Lesson 8. This is Example 3 about earthquakes. In column 1 is the days, and in column 2 is the aftershock. And the goal is to figure out at what time is it going to get to a 3 on the Richter scale, because that's when it's safe to return to the area. So to figure out the model that best fits the data, we're going to insert this data into the calculator. So you'll need to hit Stat, Edit, and in List 1 you will put your data. And hopefully you're following along right now and inserting your data into List 1. You want to be careful when you insert your data that you don't make any mistakes, because any mistake will make the equation inaccurate. And then in List 2, you're going to put the corresponding number. So in this case, it's the level of the, on the Richter scale, the aftershock. So bear with me as I finish, please. And hopefully you're inserting the data as well. If there was existing data in here, you could have just cleared the list, or you could have typed on top of it, or you could reset your RAM and that will clear the list as well. But if you delete it, you're going to have to reset the RAM as also. Okay, so there's the data. It is in List 1, List 2. I want to look at the data before I actually do a regression, so I know if it's linear, if it's exponential. If I'm not sure, I need to look. So I go to y equals, and I'm going to turn a plot on. So you highlight plot 1 and hit enter. The plot is now on, and if you hit zoom stat, which is actually number 9, zoom 9, it will fit the data. So it's arguable that this is exponential decay. It could be linear, but they're telling us it's assuming it's exponential decreasing. So we know we're going to use an exponential model. So to figure out the equation that best fits it, we're going to hit Stat, arrow over to Calc, and then we're going to go down to the model that we're looking at, which is exponential regression. We hit Enter. Now, my calculator is not as advanced as some of yours, so you might need to hit Enter a couple times. So now we're ready to write the equation in y equals a times b to the x. A is 7.44 if I round to the hundredths place, times b 0.95 if I round to the hundredths place, to the x. X being the number of days and y being the aftershock reading. Okay. The whole point of finding these models is to make predictions. So the goal is to find out when will it safely return to a level 3, So in this case, we're going to make y equals 3. So we have 3 equals 7.44 times 0.95x. I'm going to divide both sides by 7.44. So I'll do that on my calculator. 7 divided by 7.44. I have 0.403 or 0.40. The more often you round, the less accurate your answer is going to be. So really, you should really be rounding at the end, but that's okay. Now we're going to take the natural log of both sides, and that'll bring the variable out in front. And I'm going to divide both sides by the natural log of 0.95. So I'll do that on my calculator. Natural log 0.4 divided by natural log 0.95. Close that off, hit enter. It'll tell you in about 17.8 days. So to be sure, it's probably 18 days is the best answer. So at 18 days, it will have returned to a safe level. So again, to reiterate, we use the calculator to input the raw data to find the exponential regression model, and we use this model to make a prediction. Hopefully this helps, and you're going to use this to prepare for your unit test. Thanks.